first A I've gotten in like series. Honestly. Wait. This isn't.
Oh, you're not already doing it? What's the deal?
Ah.
What about what your work looks like for the first one? Notice I didn't just say converges or just say converges absolutely. Alternating series converges absolutely. Didn't even need that alternating negative to converge. It converged in, right?
Oh.
Great. Hopefully you check the divergence theorem, the terms go to zero. We found that it did not absolutely converge because without the negative it's just a p-series, yeah? Okay, so then you're on to conditional. What are the three requirements for conditional convergence besides not absolutely converging? Alternating. Is this an alternating series? Yes. Alternating series. Check. What's the next condition? The terms go to zero. I kind of already said that, but I just like to have all my conditions in the same place, so I'm going to say it again. This one, I think I went a little crazy in making you show so much work for the inequality. If it's obvious, it's okay to say, you know what, 2 over root n plus 1 is definitely less than 2 over root n. So the terms are decreasing is really what that means. All the inequality work I made you do yesterday, unless it is not obvious, I think you can jump to where it's obvious. You with me? So we conclude the alternating series converges conditionally. Right? All right. That's yesterday's stuff. Is it going okay? Yes. Today is a little more fun because it's actually dealing with some numbers again, not just a bunch of writing. It's alternating series, but error bound. Now, each of these involves an actual infinite sum, and it would be great if I could actually add them and get an infinite sum. Do I have a cord here? Yep. But the only thing I can usually find a sum for is geometric and telescoping, and the rest I just estimate with a partial sum. Anytime I estimate, I would like to know, is my estimate any good or not? For some things like trapezoids, we have an error. You know, we give an estimate, we can say, I know the error is not more than a tenth. There's actually a very logical and easy to use error bound for alternating series. Way easier than all that trapezoid b minus a over 12n squared max. Way easier than that. Okay? To see where it comes from rather than just say boom, it's this. Let's get a feel for this. Would you start this, actually, would you change this to n plus 1 up there? I would prefer it to be. Yeah, I think it goes better with notes. All right. Now, would you tell me what are the first 7 terms of this series? 1 over 1 or 1? And plus or minus? Minus 1 over 2, plus 1 over 3, minus 1 over 4, plus 1 over 5, minus 1 over 6, plus 1 over 7. Yay? All right. This will take a second, especially for you calculator-dependent turkeys, but would you find the first 5 partial sums? All right, those are my partial sums. Do you agree? Or not so much? You disagree with which one? Oh, 1/5 is positive. Not bad. Okay, thank you. Okay, so 35, 47, 60th? Yes. All right. Now, if we graph these partial sums to illustrate a point, we're going to graph 5 of them. And they all seem to be in the region of between 0 and 1, so we can make a max of our graph 1. And then the first partial sum is 1. Second partial sum is a half. Third partial sum is 5, 6. So above a half, but less than 1. Fourth partial sum is 7 twelfths. That's really less than 10 twelfths, so it's below here. 47 60ths is a little above. Must be above because we added the fifth. So it feels like the partial sums look something like that, yeah? Now, I think that is interesting. Would you try and estimate the true infinite sum with a dotted line? Put where you think the infinite sum would be. The true, if you just kept adding forever. Where would S be? This should be S1, this should be S2. So I'm saying in here somewhere. Yeah? Now, anytime you use S with no subscript, it implies the infinite sum. So when I say what's S, you're saying what's the true value if I added forever until I died and then kept going. Okay? Now, this part really confounded the other students, but again, it's 5th period, so what are you going to do? This is S1, this is S2, this is S3, this is S4, this is S5, and that's true S. Now, of those, when I say a string of inequalities, I want the least through the greatest in order. So what's the least? S2, okay? And the next least? S4. And the next least? S, the true infinite sum S is next. And then S5, and then S3, and then S1. Okay. I changed the index, so I'm going to have to make a little adjustments to my notes here. All right. So, if I were how this goes. Like I said, I wish I would have changed my notes, but it just didn't go well in last class. All right, so would you just, if I wanted to just talk about how much error is in using S1, okay? Now surely S1 is an overestimate of the true sum, and it has some error. Let's change this to, actually I'm going to change this to inequality for S2, S3, and S. And this will give me an estimate on how much error I have just a second here. Now, how do those arrange in order? Looking back at just those three, wouldn't you agree that S2 is less than the true infinite sum, and that's less than the upper or overestimate S3? Do you agree?
Yes.
Okay. All right. Now, would you give me an expression for the error in S2? S2 is not the infinite sum, and therefore, because it's an estimate that's a little off, it's got to have error. What is the error in S2? S2 minus S, yeah? It's the difference in between the true infinite sum and S2. Cool. Okay? Now, if I wanted to get this expression in my inequality, or at least without respect to sign, I could subtract S2 from each. Right? Now, if I subtract S2 from each, then I would get something like 0 is less than S2 minus S is less than S3 minus S2, yeah? In other words, I subtracted S2 from each of the three parts. You follow? Okay. Are you okay?
Wouldn't you subtract S2? Yeah.
Why is S2 easier?
Oh yeah, you're saying, don't you want S2 minus S? No, I don't. I want to subtract S2. Yeah, just trust me. Okay.
But should S2 be negative?
So that's actually, so let's talk about this. Is this even in order right now? Is S2 less or greater? S2 is less, so S2 minus S should be negative. So that right there feels like it's got an error. It should be S2 minus S is,
Or S minus S2?
I shouldn't have changed my notes. Darn it. All right. So I guess we're going to have to think on the fly. So we have a problem right now because S2 is, this is negative, and I'm getting that that's greater than negative, yeah? Or a negative is greater than 0, which we know not to be true, right?
Wasn't it positive S and then you subtracted S2? Yeah. Shouldn't it be S minus S2? So it's S minus S2.
So if I divide by a negative, then I get something like this.
But no, you said you were subtracting S2 from the entire equation.
Oh, yes, I did. I subtracted S2 from the entire equation.
It should be S minus S2.
Oh, you're saying this should be, oh, my bad. Okay, that's better. Now that's positive, do you agree?
Yes. Yes.
Okay, sorry. I'm sorry. All right, so now to the original point. Phew, I didn't break math. I thought I just ruined all math. All right, now by cleanup, the left side is fine, 0 is what it is. S minus S2 is super wonderful because that represents the error. Leave it alone. But the far right side, it cleans up. What is S3 minus S2? How would you find S3? How is S3 found? It's, you find it by taking,
S1 plus S2.
not S2, A1 plus A2 plus A3. In other words, you add the first three terms to get S3, right? And how do you find S2? A1 plus A2. So then I ask you again, what's the difference between the second and the third partial sum? It's just by the third term you add it, right? That's the only difference. All right, now that, whether you know it or not, is pretty stinking great, because that implies that the error in using two terms to estimate must be less than the next term that you left off for the third term. And that's true for, rather than go through all this stuff, this is true at all levels, with the problem being that sometimes the difference is negative. So think about, what about negatives, dot, 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 dot. So imagine I went back and did using S1 and S2, which I kind of skipped over. If you notice, we jumped straight to 2 and 3, right? And I never even touched it, right? Part of that's because there's a negative in there that makes the conclusion a little harder, and that's not a good way to start. So if I look at S1, 2, and 3, S1 is greater, S2 is less, or sorry, S1, 2, and the true sum, it goes S2 is less than S, which is less than S1, right? Do you agree? Okay. So S2 is less than S, which is less than S1. Now, if we want to talk about error in S1, you always talk about the error in the lower number of terms. So in that case, this is S1. Then what is the error in S1? It's the difference between the true infinite sum and S1, right? Are you with me? Okay. The problem with that, though, is that going to be positive or negative? S minus S1 is going to be negative. Now that's a problem. That's negative because S1 is greater, right? So now let's, to deal with that, we're going to use some absolute value because we don't really want to talk about the direction of the error. So we'll deal with this with absolute value in a second, but do you agree that we want to subtract S1 from each side? S2 minus S1 is less than S minus S1, which is less than 0. Agree? Now that I feel still is true because S2 is less than S1, that would be a negative, and less than 0. S is less than S1, so that's negative. Cool? All right. Now, what is S2 minus S1? A2. All right. Now, if we want to talk about the sign not being important, in other words, I don't care about whether it's a minute, it's underestimating or overestimating, just how far off is it? How much error? I don't care which direction. Then we use absolute value. Or we could actually just go through and divide by a negative also. But the idea is that removing the sign, we'd say the error in S1 is less than or equal to A2. I could have divided through by a negative to get to that point. But the idea is, it doesn't matter with the sign, absolute value for error, because sometimes we're going to get an over and underestimate and we don't care. Now, the idea of the day then is alternating series are bounded. So you need to cross out this part, which is an error. If this series is an alternating series that satisfies the three conditions that we use for conditional convergence. Now that doesn't mean it has to be conditionally converted. Let's put people out. I said it has to be the case that it's alternating, the terms go to 0, and the terms decrease. Then this error bound is in effect. Now you might ask, if you're really smart, you might say, well, wait a second, aren't these the same? How's it different? Conditional convergence, remember yesterday, is not absolute converging. I'm having a rough day. Okay. Conditional convergence is not absolutely convergent, and these conditions are met. Now, that doesn't matter if it is or isn't absolutely convergent. It just has to meet these conditions. If that's the case, then the error in using n terms is less than the next term in the sequence. Let's get to an actual problem, and you'll see how this works. Okay? So, using the same series, which was negative 1 to the n plus 1 over n, starting at 1. Am I correct there?
Yes.
Okay. Show the error in S6 is less than 1/5. Now, let's go here. First of all, before you use this alternating series error bound, you have to show the conditions for the error bound are met before you use the error bound. All right. Is it an alternating series? Yes, it is. Do the terms go to 0?
Yes.
Yes, they do. Wouldn't you say that terms decrease, which is to say the n plus 1th term is less than the nth term? 1 over n plus 1 would be less than 1 over n, which implies that the terms are decreasing. Right? All right. Therefore, because it meets the conditions, this is where we're at. If it's a series that those conditions are met, then the error bound on using n terms must be less than the next term. So because the conditions are met, we can say the error in using 6 terms will be less than or equal to the 7. If we stop at 6, then the error in using only 6 would be no more than the 7th term and the next term in the sequence. What is the 7th term in the sequence? 1/7. All right. So that doesn't mean the error is 1/7. It just means the error is no more than 1/7. Now our question was, this happens on the AP test a lot. 1/5 actually isn't anywhere in here, but can we conclude that if the error is less than a 7th, then it also must be less than a 5th? Yeah, 1/7 is less than a 5th. So if our error is less than a 7th, then our error is less than a 5th as well. Follow? All right. Try one on your own. Now first change, I got a little too rough too fast here. So will you change the starting index to 1 and instead change the sum to 5? 1 and 5, change those please. And then do this on your own or with your math amigos. have to start to get some of these memorized. By the end of this semester, you probably have up to about 8 or so memorized. But you know, 1 over 6 factorial is 1 over 720. Is that not less than 1/500? Yes, it is less than 1/700 is less than 1/500. Right? Did that go okay? Questions? Okay?
didn't have to find S5 there. Like,
No, okay, so, good question. It's not often that the textbooks say, well, actually, once in a while they'll say, find an S5 estimate of the true sum and show that the error in your estimate is less than.
like how
Right, this question didn't ask you this. Did it?
doesn't it find S5?
Oh, it sure does. My bad, so I never did that. Did you find S5?
No.
Oh, what is it? Okay, so S5, throw it in your calculator real quick. I would just type in, do you know what the summation is in your calculator? We've talked about that. Ay. Sorry, I am really not on my game today. The summation button is easiest found in the menu of functions next to the 9 in the subcatalog. If you go there, that's usually going to be the easiest place to find or to sum this stuff. Okay, so n equals 1. Oops. What did I say? Through 5? Now we removed the alternating negative for the purposes of the error bound. Does the alternating negative affect the sum? Surely it does, and so you definitely need it in there for that part of it to the n plus 1 divided by n factorial. Factorial's in here, or not. Where's factorial? Oh, yeah. Oh, darn it. It's in here. Okay, cool, thank you. All right, so 1930s, are we cool? Okay, is there any more on that? Is there another example? Oh, yes. Okay, so S5 is 1930s. Now, this will start to look a little like trapezoids. Sometimes you're going to have to find how many terms would it take to get the error less than a certain mark. So in this case, for example, given this series, if I wanted to, factorial, sorry. If I want to get this infinite sum estimated so that the error in my estimate is less than 1/20,000th off, then I don't need to prove convergence again. I already proved the conditions are met. But I need to find n so that the number of terms added is less than 1/20,000th. Well, if I could just find a term that's less than 1/20,000th, then wouldn't my error have to be less than that as well?
Yes.
If my error is less than that term and that term is less than 1/20,000th, then the error is less than 1/20,000th. So find the term that's less than 1/20,000th. Now that, unfortunately, is not done algebraically. Normally I would say, I just cross multiply and I say I need to find the first time n plus 1 factorial is greater than 20,000. And I would usually solve that by doing inverse algebra. Factorial doesn't have an inverse. There is no inverse operation for factorial, so it's trial and error time. Okay? Now, 6 factorial is 720. 7 factorial would be about 5,000-ish, yeah. 7 times 6, 700 is about 4,000. You multiply by an 8, boom, you're there, and you're talking, it would need to be 8 factorial. N plus 1 needs to be 8, yeah? So n needs to be 7, okay? So if you found the first 7 terms, you would need to get the error less than 120,000.
Sure, can't you just put like a million and it still be correct?
I suppose that's true. Usually the question, well worded, would say, what's the least number of terms
Well,
possible? Yes. You're just like those weasels in my pre-algebra class.
I thought you loved your field.
Not when so I gave them this, they're estimating roots, and some Weisenheimer, maybe Nathan Harvey Jr., said it's between 0 and 100. Well, you got me, you're right, it is between 0 and 100. So now I have to say which consecutive integers is it between, and which, Nathan, I'm asking you, what's the least number of terms? Find the least number of terms required to get error less than. Go. Now this one's new, so you do have to meet the condition before you go to the error boundary. I will let you cut a little corner in terms of the inequality. If you just say n plus 1 over 2 to the n plus 1 is less than n over 2 to the n, so the terms are decreasing, that I'm okay with, although showing that is a bit of a humdinger. We have bigger fish to fry, so it can be shown better. But you're just gaining a little in the top, but a 2 in the bottom, so.
If you get a negative number,
There's absolute values all over the place, so it should.
no, but like
Oh, for your sum?
for the sum,
That's
the
possible.
negative one term,
There's no negative one.
but that's what I got it.
No, there is no D. N starts at 1 and goes to N. So it has to be above 1.
Oh wait.
So I tried cranking out some algebra on this, and I basically ran into a wall. I guess you can love these two. So yeah, trial and error. And I should like this. I think it would be easier for others. Maybe I'll just graph this. What do you think? I'm not seeing it in 0 to 10, that's for sure. 12. So 12 is a little shy, so it's above that, so 13. So n equal 13. Obviously, n needs to be an integer, it can't be a decimal number. So you would need 13 terms. It's the least before you get to the error bound ID. You follow? All right. That's that. Questions on last night's homework? 138 questions. 16.
I got 12.
Also, for number one, we have to find the error bounds for those.
Say it again.
For number one, like in the backward book, they showed like the error.
No, it isn't about area. Oh, they did it by a difference. I see.
So what did you say?
So that's actually possible because it's changing. So they're obviously trying to set the station. Okay, just 16 then? We cool?
Wait. Can you also do
Yeah.
19,
19,
15, and 22?
19,
Do 16 first.
16, 19, and 22. Did you say 15 or no?
I go to 15.
16, 19, 15, 22. Okay. 16 is secant cubed. A rather famous integral because it's how you do a lot of arc length calculations with trig sub. A lot of trig sub on arc length results in this. So this is why this is an important question. It is a little bit of identity and a little bit of circular integration, right? So, with that, if you break it up, I think you'll feel like it's pretty good ultraviolet voodoo where U is secant and dV is secant squared. Du therefore is secant tangent and V is tangent. So, we get something like, is that what I want to do? Does that make things better or worse? Gosh, I wish I would have reviewed this. It's been a while. Secant tangent. Antiderivative of secant tangent squared. I agree. Right? Or tangent squared secant.
Yeah.
You with me?
Yeah. And you break the tangents.
Okay, then the tangent then gets replaced with secant squared minus 1. You follow? Are you with me? What? Oh, okay. So we have secant tangent minus the integral of secant cubed if I distribute plus the integral of secant. Are you tracking? I distributed the secant and separated the integrals. Are you with me? Or not? I actually need a second to take in what we're doing here. Okay? Now the beauty of that is that with circular integration I can move that secant cubed over with this secant cubed and get 2 secant cubed equal to secant tangent minus, or plus rather, what's the antiderivative of secant? Log of secant plus tangent, and so the true answer would be 1/2 of secant tangent plus 1/2 of log of secant plus tangent. Right? Are we cool? Okay. 19. 19 is still a question. Anybody need 19 still?
Yes.
Hey, 19, the technique. First of all, is this a improper integral where I need to do limits, or is this continuous over the integral? Is there a vertical asymptote in this region? There isn't, so it's good. I don't have to do any limits, that's not the issue. So I imagine the question is integration technique. How do you integrate it? Split it up, yes. So when you split it up, I'm of the mind that I would rather not use sub this, but I guess if you want to use sub that, you can. The first one I would probably just use sub off to the side and find the antiderivative so you don't have to change the limits, but you could change the limits. Do you want to, so use sub this and arctangent that, and you should be good. If we have an error still, let me know and we'll go through the details of it. Okay? Safe way to go is to change the limits. Another way to go is to do the antiderivative off to the side. Okay, 22. Question on 22? Yay? Yay?
Yay.
Yay. 22, the second derivative needs to be found.
Oh my God.
Are you okay? Okie doke. Second derivative needs to be found here. What kind of graph is that, by the way? It's a hyperbola. Opening sideways or vertically? X squared minus y squared, then it's sideways, yeah? All right. The only reason I don't want that to go dead is because that comes out in Calc 3. You do a lot of conic sections in 3 dimensions, and Calc 3 is pretty sweet. All right. At any rate, maybe if we have time, we'll take the data and anyways. If I differentiate, did you get your first derivative is 2x minus 2y dy dx equals 0. You should then solve for dy dx. Do not take another derivative until you know dy dx. dy dx is x over y, yay?
Is it a negative x or? Oh, no.
It feels like you'd subtract and then divide by a negative, so it'd be positive, yeah?
You're correct.
Okay, so the second derivative then by quotient rule is low y d high 1 minus high x d low dy dx. Now dy dx is x over y, yeah? Over the square of what's below. So there's the second derivative. If you want, you can clean it up, but I'm fine if you just left it. Cool? Is there any more to that, or is that it?
Well, I don't know. I just don't understand how they got a negative 10. But...
Negative 10.
Oh, because they used x. Never mind.
Oh, they might have substituted the equation itself back into the derivative, which is not here.
Okay.
Actually, maybe for multiple choice, would be bad practice to see where they're coming from.
That makes sense.
So, do you get it? But
Yeah.
Okay. You do sometimes need to do that to find a multiple choice answer.
Okay.
All right. 15. Question on 15.
Yeah. It's
Just the stone. Okay.
Check them all.
Make sure on the sum that you're seeing it starts at 2, not 1.
That explains
That's
it.
probably the issue. Your A1 was probably wrong. Yes? 12, sure. 12. Yes. 12, make sure you check the first thing. What's the first thing you check? Check that it has a chance. And although n cubed is positive, the exponential is more powerful. And so because the terms go back and forth but get bigger, they don't approach 0, this has no chance. Okay. Any other questions? Okay. Hey, a couple of hours, huh?
Can you explain why 18's undefined, actually?
Sure. So, first of all, did you first and foremost see the discontinuity at 2?
No.
Okay, you've got to start checking for continuity. You can't just mindlessly crank out an integral, you're going to get rerun most of the time. Okay, so it's got an asymptote at 2. You would have to go from 0 to a as a approaches 2. From the left, so you'd have one limit as you approach 2 from the left, and one limit as you approach 2 from the right. I personally wouldn't get the antiderivative mixed up in all this other stuff, so I would go off to the side and I didn't, you could trig sub this or decompose it partial fraction style. I did a partial fraction. So you don't want to do this over here. Probably go off to the side and decompose it and find the antiderivative. Once you know the antiderivative, then you can bring back your result and do that limit stuff. You follow?
Yes.
So I think I can't remember. Let's continue just to crank it out and make sure it's done right. So if x equals 2, b equals 1/4, and if x equals -2, a equals -1/4. So it's the antiderivative of -1/4 over x plus 2, and positive 1/4 over x minus 2. So that this is the limit as a goes to 2 from below of -1/4 log of x minus 2 plus 1/4 log of x. No, that's plus 2. Sorry. -1/4 goes with log x plus 2, and positive 1/4 goes with x minus 2. 0 to a plus limit as b goes to 2 from below above. You get the idea. Have a nice day. It diverges, you say?
Yeah, it's undefined.
Undefined or undefined? That's what they said?
It says undefined diverging.
Okay. So it's not indeterminate, it's undefined. Okay, yes?
Would the limit comparison test make that
For which one? I would, let's see. Yes.
I did the rate.
Root test might work, or ratio test would work.
Thank you, Mr.
I don't know about the limit comparison test. Use ratio test or root test.
If I do give it a limit of 0, what does that imply?
You used what test did you use? Limit comparison test? If the limit is 0, then the test fails. Yeah. It has to be non-zero, non-infinite. Hi.
Did you also require me to go to tutoring though?
Okay.
Can you require me to?
Yuli. Sure.
Thank you.
Hunter, Claire. Got it. Okay. Oops, I forgot to pause this recording.